Life is hard.
Yeah, there was someone that asked like 5 minutes before lecture if they could just get a Zoom link and I allowed that basically. Yeah, sorry for I didn't plan for it before it to be hybrid, but I guess there were some students that needed this wouldn't have helped you. I'm sorry about that. I was planning for just in person. Yeah, but I decided like 5 minutes.
Yeah, he's going to say, I have this right now. And I'm trying to look at there's another option. But it's like, I forgot what it's called. But it shows something where it's like, it's also one that shows the audio. So that's already implemented. So I think we should kind of bypass it.
Alright everyone, we'll go ahead and get started in a couple seconds here. Alright, we're going to go ahead and get started. Trying something a little bit different today. There was, an EdSTEM post about like making a lecture hybrid because I think some people weren't coming to campus because of the shutdown yesterday. So I'm sorry for the late notice, but I did send out like a Zoom link just a few minutes before because I wanted to make sure everyone could make this lecture. So thank you for coming here if you did, make it in person, and thanks for joining online for like a sort of last minute change. But let's go ahead and get started. There's a decent amount to cover today, so I want to just get right into the announcements rather than starting with the geography game. Okay, so for the announcements, Project 2, the changes that we have requested, remember we requested changes last week, but we're going to make those due on Thursday night, okay? So, respond to all of the changes that we had made, specifically for like the different implementation. If you use sort of like the lower code quality approach, then we've requested a new approach. Have that turned in by Thursday night, okay? Also, yeah.
You mentioned it was Friday, not last week.
Oh, did I say Friday in class?
I don't think you were.
Can we make it Friday?
Okay. I thought I said Thursday, but maybe I can check the recording. If you can get it by Thursday, it's great. During Thursday's lecture, actually, I want to show like sort of the test cases for GoToLine, and so if you can get it by Thursday. I also gave a hint in last lecture, so hopefully it's just 2-3 lines that you have to modify. Try to get it in Thursday night if possible. Okay. But as y'all know, if something does come up, you can reach out, let me know, and then if you need to do Friday, that's also okay. But there was a good question on EdSTEM. Like if you're now changing your implementation to use this new approach, you have to update your design document and your diagrams and stuff. Don't worry about changing that or the process journal unless there were specific changes requested for your diagram, okay? Like mainly what we're looking for is a change to your implementation to have like the better code quality approach, and of course the other, like 2, 3, or 4 changes that we've specifically requested, okay? So get that in by Thursday, and then we'll do another round of grading, and then we'll, give you credit back for making those changes. Next is Project 3. So we've added, I sent out an announcement about this yesterday, and also updated the description in the website. so you can check the project rewrite up. We're gonna have y'all submit like a short video basically of your changes, okay? So remember in project 2 you made some screenshots of the code outline, you highlighted something and it showed the go to line feature. For project 3 you're just going to make a 6-minute video maximum. It can be shorter, maybe it should be even shorter than 6 minutes. You don't have to do like a bunch of takes if you slightly misspeak or something. It's not, that formal or like we're not expecting some very like high quality presentation there. It's mostly for us to see your sort of feature in action, okay? And there's specific directions for what you need to show. There's sort of like doing the show code outline when some code is highlighted, and then also show the feature in action when no code is highlighted, okay? And then a couple other things that you should just discuss and show us sort of your code changes, all right? The way I sort of recommend doing this is just opening up a Zoom by yourself and then sharing your screen and then recording the meeting. You can then download, when you record the meeting, you can either save it to the cloud or save it on your computer, whichever option you choose. Just make sure you download it, then submit it. You can upload it on like your Google Drive or your YouTube, and then submit the link to that video in your pull request description. Okay. Again, I'll just emphasize, please read the directions that we've put in the project rewrite up here, and I think it should help you figure out how to do the video. Are there any questions about that? About the video submission? Again, it doesn't have to be very, like high quality in terms of, I don't know, any like animations or like, transitions or anything. It's mostly for us to see the feature in action, all right? Next, project 4 has been released, okay? And I've added everything to the website, so make sure y'all are keeping up with this schedule here. We're doing our best to just update whenever the projects are released and when they're due, as well as like links to the actual write-up for it. So project 4 is going to be go to definition, and I feel a little bit bad for maybe not previewing this ahead, because I think one group's project proposal was go to definition, which is a great idea, but unfortunately it was project 4. Basically what you'll need to do, I need to fix this. Let me just show that right now, and then I'll try to push a fix after lecture. But basically what you'll need to be doing in this is, say we have, some code here. We'll have def hello, and then, we'll just say like return. If you have, a function called to hello, when you do like a double click, okay, or a control click in Mac, okay, and I think it's probably also a control click in Windows, this little menu pops up where it's cut, copy, paste, set breakpoint, clear breakpoint. Yours needs to have another option here that says go to definition, okay? And then when they click go to definition, when the user clicks go to definition, you should find sort of like the actual definition for that method and then move the cursor there, okay? I don't think it's a very difficult feature to add compared to like project 3 especially, but keep in mind that the goal of project 4 is for you to do this fully in GitHub Copilot. Yeah, question?
What if we have like 2 files, and in another files we have like go to the definition, and the method should be on the other files?
Yeah, that's a good question. We'll say it's limited to just a single file that is open, okay? Because IDLE really only supports a single file open, and so we'll keep it at that, okay? You don't have to handle the case where the function definition is in a different file. So try to use GitHub Copilot sort of exclusively, and that's how, try to use Copilot to understand the code base and then to actually make the change, okay? Use it as much as possible or as much as you're able to, and then if you really can't use Copilot for a specific spot, then you can, use traditional means, basically. Yeah? Oh, screen sharing, sorry. Okay. So hopefully those online were able to see that. If not, this will be recorded on podcast, and then you can watch after for any part that was confusing. Yeah, question.
I just have a question for project 2. For the changes to that, can we just make a commit on the same PR and just do it?
Yes. So the question is, how do we actually make the changes for project 2? Just make another git commit to the same branch that you have the pull request in, and then it'll automatically be part of the changes that we can see. okay? In general, that's how all the changes requested will go in this class, and that's also sort of like the industry practice where you'll just modify the existing pull request, okay? Rather than merging it or deleting the pull request and making a new one, you'll just make an edit to that existing pull request, okay? So yeah, for project 4, importantly, you don't have to do any design document, okay? There's no design document or diagram that we're gonna enforce. The main thing is going to be the process journal, and there are some different sort of directions for the process journal, okay? We really want to just understand like how you use the different features of GitHub Copilot, and so just please read the directions carefully for the project 4 write-up for what to include on your process journal, okay, for project 4. There's also one other piece where we're gonna ask to just see the GitHub Copilot chats that you have. So remember we showed in last lecture how there's the GitHub Copilot chat feature and you can sort of like ask any questions for code comprehension here. There's some directions that we've included for how to actually like download the GitHub Copilot chat, and you'll just like upload that as part of your sort of like process journal or part of your submission for project 4, okay? If you're just curious in like the different ways the Copilot chat feature is used. Okay, and then lastly is the code walkthrough presentation signups. So I think we're still about 3 weeks away from these code walkthrough presentations, but there's also, you can actually now check under the group project. We have the code walkthrough presentation right up here. Basically, you're going to be doing a total 15-minute presentation, but really it'll be like 12 minutes of you talking and 2 to 3 minutes of question and answer period. You'll be like creating a high-quality diagram and then also demonstrating a couple code comprehension features in front of the class, okay? You'll need to pick out a specific feature in IDLE, so that might be something that you can start discussing with your groups right now. We have a spreadsheet here where you can actually sign up for the specific topic that you want. So it looks like we already have one group that signed up for the classic theme, dark theme, light theme feature. And remember, this is an existing feature that should be in idlelib. You're not, showing your project or anything right now. You're just finding an existing, it doesn't even have to be a full feature. It can be like part of a feature. Remember, like we talked about the search text function last time? I honestly think you can do a 15-minute presentation just on search text, and that can be your project as well. It doesn't have to be the full, find feature or search feature. Are there any questions here? This is just going to be first come, first serve. So once you have a topic idea, make sure you write it down here so that you can sort of reserve that topic. Are there any questions about the code walkthrough presentation? Yeah.
Sorry, I have a question back to project 4, just for clarity. We try to use GitHub Copilot as much as possible, not like we can write some code ourselves.
Yeah. I mean, it would be interesting to use as much as possible, but if something is not working, then you can do it manually, or if it's not generating the correct code. But I think it would be helpful to just mention that in your write-up, and like what things Copilot wasn't doing well at, and then what you sort of needed to do on your own.
Got it.
Yeah, question.
I have a question about group project. So we have a 2 proposal, which proposal we do is up to us or up to the 2?
Right, okay, actually, sorry, I thought that was one of the announcements already. So the other announcement is that we have gone through your project proposals, and I think everybody should now have a comment on their GitHub issues that they've submitted. At least, the way we're doing it is there's 3 tutors and then me. And so each of us is having 3 teams. We're just looking through the proposals and commenting on the one that we're recommending. The important thing here though is that we are going to endorse one basically. We'll probably say, this is the one that I think is better to go with. If you're really passionate about the other one, you can definitely go ahead and do the other one. We're just giving our recommendation for what we think will have sort of the best educational value and what we think will make a good scope or difficulty for your project. But if you haven't gotten one, then probably 1 or 2 tutors will just get back to you very soon today. But otherwise, you can check the GitHub issue that you've already made for the group project. Okay. You should go ahead and start working on the group project. Remember that there's going to be a checkpoint 1 on May 20th. So I think in about 2 weeks, you'll just submit your first checkpoint for the final project as basically showing what you've done so far. So make sure you go ahead and get started on that. And you should have, your project proposal sort of approved by now. Are there any questions about these announcements? I know there's a lot. If you think of a question later, please post on EdSTEM sort of publicly, and then everyone can benefit from it. Well, I'll wait here for a couple seconds. Question? Yeah?
Just to add, if you are going with the other idea, the one that we didn't recommend, could you like make a comment or something saying that you're gonna go with the other one?
Yeah, that's a great idea. So like what Kushi's mentioning there is that we gave a recommendation for go ahead and do this project. If you are not going to go with the recommendation, please just let us know, okay? You can respond to our comment, or you can just comment on the other proposal that you are going to go with, but do let us know if it'll be different from what we're recommending. Are there any other questions about any of these announcements? Okay, cool. Let's move on then. Alright, so as you know, y'all are working on Project 3 right now. And Project 3 is a bit difficult, okay? It's due this week. I think it's due on Wednesday night or Thursday night. But remember, you do have the 1-day extension on it. Let me just see what the deadline is. Okay, the deadline is Wednesday night, so tomorrow night, but then you do have until Thursday night to turn it in, okay? I'm going to give a couple hints right now, so do pay attention to this because I think it's going to be really helpful for like your own implementation, all right? So the way you can think of Project 3 is there's kind of like two main obstacles here. First, you need to figure out how to like add a menu item that says like show code outline and sort of tie that to some actual like method that, you know, gets the code and then creates the outline and shows it to the Python shell. But that second thing is how do you actually write to the Python shell, okay? So I'm going to give a hint for both of these. It won't be like extremely revealing, but I think these are great starting points if you haven't, sort of figured out one of these steps. So the first one is actually just a very helpful sort of piece of example code that you can visit right now to sort of understand some of the patterns in this code base, okay? So this first one is actually called ZZDummy. Some of y'all might have actually seen this if you're looking through the file names or just reading through the documentation. This one, I would sort of recommend actually like reading this and then visiting, here let me make it larger actually, and then visiting extend.txt and config extension.def, okay? I won't go into what all is happening in the code over here, but I'll just maybe show you briefly what this extension does and how you enable it. So let me go ahead and run idle lib. There's so many windows open right now. Okay. Let's close this. Okay. So if you go to settings and then you go to extensions here, you'll see one called ZZDummy, all right? And I think before, by default, this top thing, sorry, I don't know if I can make this bigger. I don't think it actually makes this thing bigger. But anyway, when you go to extensions, I think it'll say enable editor and enable shell. These things will have a check mark next to it. If you click this button next to enable and then do, like apply and okay, you'll see when you go to like new file, let's just have like, some mock stuff here. And when you go to format, you can do Z in, okay? And it'll just like add a Z in front of everything that you have highlighted, okay? And then when you do Z out, it does sort of the opposite effect, okay? I would highly recommend looking through ZZDummy for examples on how to make, like a menu item, and then maybe read through some of, the code and the initialization here, and some of the things that happen in the actual, logic of the implementation, okay? I also will mention this extend.txt. This is just in the actual idle lib directory. It gives some very helpful information on what happens when you basically create a new extension or create a new feature in idle, okay? I think having this background would be very helpful. Yeah, question?
What was supposed to happen if the shell is closed?
If the shell is Oh yeah. Oh, great question. So that's what I'm getting to right now. Actually, let me get to that in 1 second. Though, are there any questions about like this ZZ dummy? I want to clarify that there's multiple ways to do this. You might not have even had to use this extension. You might have figured out a different way to make it work correctly. But this is just one sort of hint for how to actually add the code of interest. Okay, how to add the feature. Okay, the next question was about what happens when the idle shell is closed, okay? And that is a great question. I want to show it here right now. So let me close this. I have like 2 different, basically like workspaces, one which has all the solutions and one that I used to demo in class. So this is opening like the solution one. So right now, when only the shell is open, when we don't have a Python editor open, it should either like not say show code outline, or it should just be like grayed out here, the way that like show line numbers and show code context is, okay? But then when we go to new file, you should, when we have like the editor window open, you should see the option for show code outline. And then let me just, I don't know what happened there. So let me just copy paste some code in. Now when I do show code outline, okay, with nothing highlighted, it'll print out the full outline of the full file, right? But then the question we just had is actually something I want to point out to make sure y'all are able to handle as well, is when the Python shell is closed, okay? So right now I only have the editor window open. If you then do options, show code outline, it should open the Python shell and print the code outline, okay? So it shouldn't be the case where when you do options, show code outline, nothing happens. If nothing happens, then it's not sort of fully implemented, okay? So that is also not extremely easy to do. I'm gonna give a hint right now for how to actually interact with the Python shell. The hint here will be using the check syntax feature. So I think we actually showed this feature pretty early on, where if you do run and then check module, okay, I guess I have to save it. I won't do all that right now. But try to find where this method check module is implemented, because, or actually maybe I should show it. Let's just do print hello. So if I do, let me save this somewhere in documents, testing.py. So when you do run and check module, let me just make sure this is closed. So right now I don't have the Python shell open, only the editor window is open. If I do run, check module, it does open the Python shell, okay? Nothing was printed out because there was no syntax error here, but that can maybe give you a good idea on how to actually open the Python shell. And then if you explore sort of like the main object or the main class that is responsible for the Python shell, you'll find sort of an idea of how to actually write to the Python shell, okay? I'll give just that much right now. I'll also say the pyshell.py file is going to be very useful. You can look through the outline view, read through some of the comments there, and that should help a bit with this second part. Yeah, question?
For the project 3, is I have to write in the Python shell, because I use like a new window to show the code outline.
Yes, you do have to write to the Python shell. Rather than just opening up a new prompt or a new small tkinter text widget, it'll be specifically you should write to the Python shell. Okay? Yeah, question.
So does it matter if it prints with the arrows, kind of like this?
Oh,
so
yeah. It should. Yeah. Okay, that's another one actually. Let me add it. I think. I hope that's written in the write-up. If it's not, then I should modify it. But I'll just say the prompt should show up after. And I'll say
Oh, I didn't mean that.
Oh, sorry. Then what did you mean?
So right now, if you just do print hello world, right? You get the words hello world will 5 right there does not show up with the arrows. Does it matter if it shows up with that or the outputs?
Interesting. I don't know how you would implement it with that. Maybe it is possible. I think it's probably better to not have the arrows, because the arrows more realistically like indicate where you can actually type in a command. So I think if possible you can avoid. Do you mean at the start of the outline or every
yeah.
single line?
Just to start.
Okay, the start I think is fine. I think that's actually how mine is implemented right now. I guess nothing would show right now. I don't know if you can then remove the 3 arrows. So it's okay if it's there at the start, but for the every single line in the code outline, let's try to avoid the 3 arrows if possible.
Got it.
Okay. Okay, good questions. And again, remember, do your best on the first submission, then we will request changes and you will have some time to sort of address them. But yeah, please ask all these clarifying questions beforehand so that we can sort of avoid any confusion. Is there a question? Or, okay. Any other questions on project 3? So yeah, please come to office hours. I think tomorrow I have office hours and same with Thursday. We can sort of work through this more if you're stuck on any of these. Okay, let's get into the content for today. So I just want to finish with the GitHub Copilot demo that we had shown last time. Just so we're all on the same page, last time we had ended with an activity where you have to sort of make a modification to the show call tip method in idle. So let's just go to this like call tip.py here. And basically what we had to do is, let me just run idle lib right now. Wow, this is pretty annoying with the meeting controls. Okay, so the feature that you had to sort of like find and modify was this. When we start typing some method name, the docstring comes up. I just want to quickly show like my interaction with GitHub Copilot and some ways that you can go about using Copilot to make this happen. So you can always open up like your previous GitHub Copilot chats. So I think if you zoom out here, you can see the chat at the bottom. You can go to this, history of your chat by pressing this like history icon. And I had actually asked it. Remember, in the activity, I actually didn't tell you all the name of the feature. So one thing I wanted to sort of show here is that Copilot was able to actually figure out the feature that I needed to find just by describing it. I just mentioned, can you find where the feature is implemented that shows the function docstring comment when you type the function name and the open parentheses? It was able to find calltip.py and then calltip_w. I think we had a question in the Google form that was like, what is the difference between these 2 files? You can actually just read sort of the start of each of these files, and this calltip.py is mostly responsible for like basically the logic of implementing the call tip, like what goes into that actual call tip and how you find sort of the actual method. And then calltip_w is a bit more responsible for like the actual little widget that pops up and the positioning of it, okay? So so the next question that I had asked is like, how can we actually modify, like make a change to where the call tip shows up, right? So like right now it's showing up right underneath, and even if it's, like down here, it'll show up right underneath. What if we wanted to actually make the call tip, appear a few lines above or a few lines below? The sort of like main thing there that I was hoping y'all tried was highlighting this whole function. And then remember to have like an inline interaction with GitHub Copilot. Whatever you have highlighted, you can do Command I, okay? Once you do Command I, you can do this / for the list of commands, right? And remember, like doc will generate some documentation for whatever you've highlighted. The thing here that you can use is fix. I think fix is something that's quite useful for these large code bases where you're not always adding a completely new feature but modifying something. You can do /fix and then you'll want to say what you actually want it to do. So it'll be something like, can you modify the code so that the position of the call tip is, let's say, 3 lines below the current implementation, which is showing up where the cursor is positioned, okay? And then it'll actually sort of show you its suggestions. I'm just gonna zoom out for a second here because it's a bit easier to see. Yeah, so it'll give an explanation of what it's trying to do. It'll say to modify the code. It says you can update the get position method to calculate the new anchor index. And if we sort of look through the code, anchor index is actually like the tuple that determines where the call tip is going to be positioned. And then you have an option of either accepting or discarding changes. I'm just going to accept it. And the main thing that it actually shows, oh wow, it did make quite a big change actually. Before we had this like if else. I actually don't know if I liked its change so much. Let's just, I wish I could do that again. Oh, sweet. I didn't know this was a thing before, but I just like pressed the up arrow and it's like showing the history of the things that I had asked it. Okay, so let me do this one more time. When you highlight it and you do Command I and then just press the up arrow key, it shows like the most recent command. And yeah, so I guess this is the change that it's suggesting. We can accept it and try it. I don't want to spend too much time on this, but let's just save it and then run it one more time and see if it actually does make an impact. So let's go down here. Oh, it looks like it didn't work. So that's maybe another lesson in wanting to like verify everything that it outputs. You probably want to like undo this, and I think the better change would be something like this. When I had done this last time, I think it was suggesting this change rather than the thing that it had just suggested. But okay, let's just see if this works. Otherwise, we can move on to the content for today. Oh, that's really weird. I don't know. Maybe we won't spend more time on this, but if people did get a working version of this, I'd be interested to know. Maybe you could show me after class. Because I thought this would be the correct way to do it. Does anybody know right now how they're able to? Yeah.
Control tip.py is another function. So it's very different.
Oh, really? Okay. What was the function? Do you know?
Position.
Oh, in tooltip. Interesting.
And then,
Once you modified this.
then I just subtracted 60 from the underscore y.
Oh wow. Like this minus 60. Okay. Interesting. Yeah, let's just test this out. Okay, this looks like it went up by 60.
You should delete the call stuff for the plus 30.
Oh yeah, true. Okay, thanks. I think there is a way to get it working in this. It had actually suggested a correct fix last week before I had shown this in class. But anyway, I just wanted this to be an example of how you can use /fix, okay, to modify it. But let's maybe move on from this. Are there any questions on like the end of the Copilot sort of like lesson and how you can use it inline to understand or make modifications? Okay. All right, so let's go ahead and start today's lesson, which is going to be about unit testing, okay? So we're gonna spend, I think, 2 to 3 lectures on unit testing, and now we're sort of going to dive into how the tests happen in IDLib, and we'll even be working through adding tests for the go to line feature over the next 2 lectures, okay? So first, just like a high-level overview of the different types of tests that exist in these large code bases. And you can sort of see the different like axes here, which is like how many tests there are and kind of like the time or like the effort for these tests. So today we're just going to talk about unit tests. Unit tests are tests that'll test like individual functions, the input and output of like very small components of our code base. Then we'll have like integration tests, which will test more like, you can think of if you have like an API, like if you've ever used like the Spotify API and made some small little like web app or something that interacts with your Spotify account. There will be individual services in a certain like product, okay? For like the Spotify API, it's just like get playlist or read playlist or like song, okay? And you would just have like a set of tests that will test that feature or that service, okay? But these are a bit broader than unit tests because it's like a combination of a bunch of methods that'll implement this service or feature. And then finally, we have like end-to-end testing, and this will be stuff that tests everything from front end to back end in a single sort of test, okay? But the thing is these, take a lot more time and we'll have like much fewer of them because we'll be checking so many things from like the full stack basically, right? We'll want to test like when a user clicks like song on Spotify, we want to make sure that now that song has, an increment in the number of likes. Then we'll want to check maybe like the backend database to make sure that that song also has, updated wherever we're storing all the data. And we'll want to make sure that the front end is now updated with the new value of likes. And so there's so much more that goes into an end-to-end test that sort of encompasses the integration and unit tests, okay? And then one more thing here, if you haven't heard these terms black box and white box, you can think like black box testing and white box testing. The reason unit test is under white box testing, white box testing means that like when you have some input, you can sort of isolate what is going on in the specific code to understand why the output is giving a certain thing, okay? Unit tests, and actually like every method that you write in the sort of large code base, those methods should be very like narrowly scoped and have sort of like one main purpose, okay? And they shouldn't have like so many things happening in those methods. If you have like a good, method and a good unit test for it, it'll be very easy to figure out what is going wrong if you have a unit test and some message, some sort of test is failing, okay? The reason integration and end-to-end testing is considered black box testing is that when one of these things fails, there's a number of things that could be causing it to fail, right? For example, if like an integration test is failing, like for example, the pressing like for a Spotify song, right? If maybe something isn't updating, there's probably a few different methods that could be contributing to it. So then we want to maybe do a series of like unit tests on a specific service, or like see all the unit tests that are responsible for a specific feature or service, and that will help us sort of figure out what the actual cause of an error is, okay? So that's just white box and black box testing. I think you'll hear this maybe somewhat frequently if you, start working in industry and are responsible for writing tests for parts of the code base. Yeah.
What does it mean when it says like 10 to the n?
Yeah, so that is like the number of tests basically. I think this is more of like an estimate of like the relationship, the relative amount of these tests. You'll normally have a bunch of unit tests because there's like so many methods and there's so many smaller things that you'll want to test for a specific method. And we're gonna dive into the code base right now and see some examples of unit tests. But then I think the idea here is just that integration and end-to-end tests are much broader in scope, and so you don't need as many of them, and it also takes longer to run an integration or end-to-end test because there's so many things that are happening, okay? But yeah, this point is really interesting. I think you'll find even in the idle code base that there's actually maybe more lines of testing code than development code, and what we've been working on for the first 5 weeks has only been development code. We haven't actually even like looked into any of the testing code, but there's so much testing code that's just responsible for this code base, and that's sort of one of the learning goals I'm hoping for from today. Yeah, any other questions on this general overview of testing, okay? Or yeah, are there any questions? Okay. Let's just start with setting up our test, okay? So I'm just gonna demo this right now, and I think it would be great if you could actually follow along and set up the test on your own, because we'll be doing a couple activities where it would be helpful for you to run the test, okay? So when you have VS Code open, we've looked through some of these features on the left. This is like the advanced search. This is for Git, which I think we actually haven't covered yet. This was the debugger. This was extensions. But then this one that has like the test tube, okay, this is gonna be like the testing tab, right? And when you click the testing tab, hopefully you have an option here that says configure Python test, okay? If you don't have that option, you can do Command P that goes to the, or you can just basically go to this like command palette up here and do the arrow, and then you can type in Python configure test. Okay, so again, that's if you don't see this option. If you do see this option, then you're great. Follow along with what I'm going to be doing right now. So you'll click Configure Python Tests, and then there's two options here for Unit Test and PyTest. Click Unit Test, okay? When you click unit test, then it asks for the directory that contains all your tests, okay? For us, that's idle_test. This is just asking for what directory in the current project has all the tests. And then it asks what is the actual pattern of the test, okay? And if you don't know that, you can actually just open up the Explorer here and you can see we have idle_test, that's where all the tests are. And it looks like the format of the tests are test underscore and then whatever the actual feature was or whatever the original file was, okay? So we're gonna go with this test underscore asterisk. And then I think it'll take a second maybe, but you should eventually see a settings.json file, okay, in the .vs code directory. Remember last time we had created a launch.json file for our for using the debugger. The settings.json is going to be responsible for the unit test, okay? And then the body of settings.json should look something like this. So you can just take a second to get that set up. I'll just do it one more time actually. You can delete settings.json. You can go to testing, configure Python test, unit tests, idle_test, test underscore asterisk, and then it should open up, okay? So for this first activity, we're just gonna start with exploring the test a little bit. And this is gonna be y'all sort of reading a little bit of documentation and running a couple tests to start gaining some understanding, okay? So let's go ahead and start with activity 1. What you're gonna be reading is in idle_test, there's a readme, okay? There's a readme.txt, that's the documentation for the test in idle. I want you to just read point 1, that's called test files, and point 2, that's called GUI test, okay? It's not too long, so just read these 2 sections and answer these first 2 questions in the bit.ly, all right? If you wrap that up, you should start running a test or some of the tests in idlelib and just see what happens. Yeah, question? Or is it typer?
I'm getting a PyTest discovery error.
So, yeah, so if you got a PyTest discovery error, I think that means that when you do this configure test, you should only click unit test, not PyTest. If there is some issue, I would go to this settings.json and just delete this file and you can redo it. So you can go to settings.json, click delete. And then when you go back to the testing tab, you'll have this option again.
I don't have that option again.
You don't have this option again? So then you can go to the command palette, and when you type in this arrow, you can do Python. Oops, it's not happening right now. Give me 1 second. The unit test, idle_test, test underscore asterisk. But if you're not getting that option, you can go to the command palette, type in this arrow, and then do Python configure test. When you do Python configure test, then you get this option. We'll come around, the course staff will come around and help you with getting it set up, but I think the priority right now is reading through the documentation, answering these couple questions as we come around it.
Yes, sir. I still get deeper. I do get settings.
Yeah, so let's just delete that file.
No, sir, yeah, I just ran through it again, 1 second, and then I get this. So I get it right, it's just that I do it together.
Can we just like delete it and render it one more time? I want to make sure that.
No, when you're gonna do your
So you can check your grade on Canvas and go right like 0 if you have.
Oh.
If I forget something.
Yeah, we're trying to do Canvas grades, but I think we had mentioned as well, we're trying to do email you a copy of your response, but I'm not sure if these forms have it.
The lecture there was a response.
Yeah, for last lecture, I was here, I commented, I created 2 back.
Yeah.
Commented on and I was
We
able
want
to.
to make a private SM post with the lecture that you're getting 0 for, and then we can go back and check.
Take that down.
Yeah, if you make the post, then I'll just check manually for the. Okay, yeah, you do get the 4 missed lecture.
No, but I do want to miss another lecture.
Yeah, okay,
For a lecture I actually missed.
Yeah.
Yeah.
So.
Okay, so configure test, click through.
Yeah. This one.
Then, it should create the settings of JSON. You can just close your VS Code and reopen it, and test the settings of JSON. Where's now test browser? Oh, we're so maybe a little bit.
Yeah.
You might have to close all of them.
No, I did.
Oh, yeah.
Because the errors of the US computer. So we can use like using SQL. Or just modify the editor in the class.
But they were only set up college.
specific director.
Can't correct.
I'm not
I think down there, and can you click on items? And just like go to one. And then, oh wait.
And then start VS.
Okay. Oh, okay, this is how it should be.
Okay.
Now, yeah, you can go ahead and start. And then configure
Go to the account, configure test.
this, and the last one. Yes. And then,
Test back underscores asterisk. That's how it's test underscore asterisk.
fine, can you go back to the.
Yeah, now it's.
Do you want to just close your VS Code and restart it? You might have to redo the settings. Just maybe like quit the app.
I don't test. There's a reason.
Oh, there's readme set up.
Okay, so,
And then
you can go to your settings on JSON.
Oh, readme.txt. No, inside
Don't try
readme.txt.
closing your VS Code and restarting it. Typically what it does
Should we do
is
the top?
it needs to set your JSON file, so since it just created it, you might.
Should we go hold the test?
Yeah, I'm facing everywhere else.
Okay, you can just close your.
You already, oh, you made settings. Go to, no, go to your, go to.
So, for those of you that are still seeing like the PyTest discovery error over here, after you create the settings.json, it should again look like this, I have a copy pasted version in the slides. Just close your VS Code and restart it. The way it actually sets up the test over here is it reads in the settings.json file, okay? So it might just be an issue where it hasn't sort of like parsed the settings.json and configured the workspace. If that's still not working though, then raise your hand and let me know.
Another solution is do a pip install PyTest.
Oh, okay.
Because you might be missing a module or something.
Okay. Yeah.
It'll take me. Yeah, it took some time with me.
Yes. Requires transition to,
Good test.
I'll talk to the team.
is there any extra further opportunity because I missed all the exploration?
Okay.
You'll definitely get some really specific, but I haven't.
So this is
So we can bring in extra credit about talk to the team.
I see that this is like the reality, but
Okay, so let's wrap up the activity in the next minute here.
Oh, is there reading in the I/O test? In the test. Oh, yeah.
I need some information. Oh, wait. Oh, you ran this test? I just sent it by the end.
All right, let's get the activity 1 answers submitted. Okay, let's go ahead and discuss what we found out from the README here, right? So let's start with this first question. Can somebody just explain what a GUI test is based on what they have read in the reading? Anybody want to share? Yeah.
Something about creating a teacher like widget. I assume like creating and having.
Yeah, basically. So like a GUI, if you haven't heard that before, is stands for graphical user interface. It's basically like anything that has an actual thing that you can interact with, okay? So you can describe like IDLE as a GUI application, a graphical user interface application, because it actually like pops up an editor and then we like interact with it, okay? But there's other sort of code bases that aren't GUI applications, right? So if you think of like, if you've ever used, let me just search it up, matplotlib, okay? So if you've ever used matplotlib, this is, an open source code base that is responsible for like making visualizations, okay? But the actual code base is just, the way you actually use it is just like, in a Python code, you'll say import matplotlib and then like plt.hist or something, okay? And then it'll open up, it'll make some actual visualization or diagram, but this code base itself is not a GUI application, okay? And so the sort of interesting thing here is that there's tests that we need to do for the actual graphical user interface, all right? We want to make sure that things are responding the way that they should when we like click something, when we scroll something. And so basically the main takeaway here is that there are going to be some tests in IDLE that are GUI tests that are meant to check like the graph, like the sort of interactive component of it, or the thing that we actually visualize, okay? But on the other hand, we have, maybe we'll just call them like non-GUI tests, okay? Which are not testing like how things look or how things respond, but maybe just the logic of the actual code itself, all right? So was somebody able to just find a GUI test that I can go to right now? Maybe someone can just say the name of the test or the name of the file, and I'll navigate to it. Yeah.
The test colorizer.
Test colorizer. Maybe just the
file. Yeah.
Okay, awesome. So yeah, when you see a GUI test, I think all of them in the IDLE code base have the requires GUI. This is basically just saying like we'll only do this test sort of like if we have this setup or the configuration for running a GUI test. But then we see these like setup class and tear down class methods, right? Can someone tell me what the setup class and tear down class seem to be doing? Yeah.
They like create the TK root object and then the tear down just like
destroys it. Yeah, awesome. So the main takeaway here is that the setup class and tear down class, you'll see these mostly in GUI tests. There are other ones that do have setup class. But I think if you read the README, it mentions sort of like the purpose of these. And the reason is like when we run like all the tests at once, okay, and to actually see how that works, you can actually click the run button on this like IDLE_test thing that shows up, and it'll run sort of like every single test that it can, okay? So it'll run like a bunch of tests at in parallel or sequentially. But if we have a bunch of these GUI tests happening, we'll open like a tkinter text widget, we'll do some test on there, but then we want to make sure we close it and only like test out the specific feature that we wanted to in that instance of the tkinter text widget, right? We don't want to have like a bunch of GUI tests happening on the same tkinter text widget because so many things might be like interacting with each other. We might add some text to a text widget and then try to read that. But then if another sort of test is also writing to it or deleting from it, we just have like way too much sort of like going on at once, and we want to maybe like isolate the tests from each other. Okay, so that's sort of like the purpose of this setup class and tear down class. But now I want to sort of get into like the lecture component of this, where I'll talk a bit about like what a unit test does, and then this concept called mocking. Okay, so testing is a very like there's so much design that actually goes into writing a bunch of unit tests for a specific code base. And this setup class and teardown class is a pretty universal like archetype or like pattern that you'll see in other languages as well. Okay. So the example that I actually want to show here is test_history. And I think we had actually worked with this before. And also a little shortcut here. When you're going through all the idle_test tests, you can see these different files. You can expand it to see the actual test within them. And if you click this rightmost thing here, it'll actually just go to that test, okay? So if we go to store test, we look at store test, we have a setup class here where it looks like we have cls.text equals make text. And I think this is probably something we haven't really seen before. What is a class method? I would recommend sort of Googling this and reading up a bit about it, but a class method in short is like, rather than a sort of method that you can run on an instance of a class. So you know how we have like the editor window, and then we can do like, maybe that's not a great example. When we have these are like instance methods, okay? We'll have tear down and then they'll say self. When it says self, this is an instance method for like a method inside of a class, okay? It means that we can create an instance of the store test class and then do like that object dot tear down, okay? And it'll run this method on that sort of like instance of the class, not like via class-wide sort of like setting or attribute that exists for like every version of that class, okay? And just to clarify there, when I say an instance of a class, that's like when we actually initialize the class and have something that is like a tangible version of just the class that we are dealing with, okay? Setup class, or these things that are class methods, are something that like will be applied to every sort of instance of a class. So it's kind of like a global setting or global configuration for every instance of store test that we have, okay? That might be a little bit confusing, but I think it's not too crucial to understand here. Maybe something that might help a little bit more is what I'm about to show now, which is how this like setup class and teardown actually run when we run like all of these tests, okay? So right now we have this store test class, we have setup class, and we have teardown, but then we have all these other tests, okay? We have test init, we have test store short, test store duplicates, and test store reset, okay? What I'm gonna do right now is actually just run the store test tests, and let's see the output at the bottom here. So let me just close all this. When I run store test, okay, I had added print statements here, okay? These print statements are not gonna be here in your version, but I've printed out like setting up class and then tear down and then each of the tests, okay? And what we can actually see is at the very beginning, it's printing out setting up class, okay? And then it'll actually run test init, okay? It'll print out test init with the lowercase I here. And then it'll print out these three dots. These three dots are just something that automatically get printed out as part of the unit test framework. When something is just like passing and working, they'll print out a dot and it'll print out okay. But then you can see that it'll print out test init, then it'll say tear down. Then it's running test store duplicate, and then it's tearing something down, okay? I wonder why it's saying tear down twice. That's a bit interesting. But in short, you'll see that it'll print out like the name of the test as expected, and then it runs tear down. The takeaway here is that it's running tear down after every individual test, but it runs set up class just at the very beginning of the class, okay? This is just to set up like all of the future individual unit tests that we're going to run, okay? And tear down is something that just happens at the end of every individual sort of test. We're just basically resetting our sort of like test infrastructure to where it was before we ran that test, okay? And you can actually kind of just read the body of teardown to see what's actually happening. It looks like we're just basically deleting everything from the text attribute in our sort of like test infrastructure, all right? Are there questions here on what like setup class and what teardown is doing? And then keep in mind, there's also a teardown class that is more in the GUI test that just like deletes anything that was created in setup class. Does this make sense? Yeah.
Could you repeat what the class method thing?
Yeah, this, I think I'll definitely recommend Googling it on your own because even I think I'm a bit unclear on what exactly it's doing. This, I don't think exists in other languages, this like decorator, this like add class method. But the difference here is a class method isn't something that is run on an instance of a class, okay? So let me just maybe, this is a bit more general to like object-oriented programming. But let's say we have, you know, the editor window, okay? And when we go to, let's go to editor window. So editor window is a class here, right? And then it'll have some initialization, right? When we initialize an editor window object, then we can run like all of these different methods like set status bar, set line and column. These methods are called instance methods. And we run them on like an instance of editor window once we like initialize and create an editor window object, okay? These class methods they don't require an actual object to be created to actually run them, okay? You can just do like, what were we just at? We were at store test. You can actually just do like store test dot set up class and then it'll run this stuff, okay? You don't have to like initialize a store test object and then run these things. That would be something that happens like in teardown or test init, okay? Where it says self as the parameter. When we have a class method, we don't need an object to run it on. We can just run it on like the class itself by doing something like, it would look like store test dot setup class, okay? Like that's just the difference between a class method and an instance method. Okay? Okay, any other questions just on this? Like what a test looks like? Alright, so now I want to get into one of the more interesting concepts, which is going to be mocking, okay? So I'll do this in like a simple example that most of us have seen. Let's say we're writing this method called write name to file, okay? And all it does is it'll open up some file, it'll write our name to it, and then it'll close the file, okay? Say I'm working on just like some other application. And this is the method that I've written. One way to sort of test this that honestly makes a lot of logical sense is we'll create like some dummy variable called first name and last name, and then we'll run the method that we had written, right? We had written the method write name to file, so I'm just gonna go back. This was the initial method that we had written. And then to test it, we'll just actually write our name to some file called like temp config. And then we'll open temp config and just make sure that whatever we read from that file is equal to, you know, what it actually should be, right? Based on this like simple example that we created. This makes a lot of sense, and it would like realistically check if our write name to file method worked. But does anybody have any thoughts on like whether this is a good idea, or if it's not, like maybe why not? Why wouldn't we want to do something like this? Anybody just have a guess? It's okay if you're wrong. Yeah.
If you run this multiple times, would it write the name multiple times?
Oh, interesting. I think so. If you run this test like back to back, basically what would happen? That's a great point, actually. I think what we want to do is make sure in this test case we have a close where we like close the file name or like erase everything from the file. That's probably, I think you're right. I think that would be an issue with this test, but it wasn't what I had in mind. Is there another answer someone has thought of? Okay, so the issue here is that these methods, open, write, and close, these are all sort of like methods that are already existing in Python, okay? okay? And say we're working on some like separate application that just uses these, we don't actually need to make sure that like the open, the write, and the close work as intended, because this is something completely outside the scope of like our application, okay? What we would really want to do is make sure that we would just want to make sure that these methods are called with the correct arguments, okay? Because all we want to make sure happens is that like when we sort of like call our method, it uses, you know, the correct parameters that we are hoping for it to, and we're just sort of going to abstract away the logic of the functions that we don't have to implement or that we don't care about, okay? And that's, you know, specific to this sort of like toy example that I came up with, because these are inbuilt features, okay? The main point here is that this test case, this example test case that I sort of showed, really what this is doing is actually testing the inbuilt Python methods, okay? It's also testing, you know, that right name the file is called with the correct parameters, but the way we're actually verifying that is by reading out from some file and making sure that it's correct, okay? But one thing to really keep in mind for writing tests is that we want to have very narrow tests that are specific to the functionality that we implemented, okay? So, one other reason I also want to point out for why this wouldn't be so great is that this test that we would have written, it's very bulky in that it actually requires us to open a file, read from it, and then eventually close it, okay? What we could actually do is maybe have something that's called a mock of these functions that doesn't require us to actually write to a whole file, open that file, and read from it. We can maybe have like a simplified version of a file and just check if that simplified version has the sort of expected value that we want, okay? And so to make this a bit more clear, I'm gonna show how this actually works in the idle code base, and yeah, maybe we'll have time for the activity after this. Let's see though. So you can follow me right now. We can go to the test format, so the find test feature, the find test. So find test. Okay. So when you go to find test here, what I wanted to show. Oh wait, is that right? Okay, yeah. So you'll see in the setup class here, we have this import statement. Okay. We have from idlelib idletest.mocktk import text, okay? And then we are initializing this text object, and then it looks like we're using this, right? We're like inserting something to that text widget. We're maybe like asserting that something is there, we're deleting it. And then we have a few of these other tests, but let's not worry about this for now, okay? Let's focus on this like run case method. So what we should focus on is this like mock_tk import text, okay? And it actually looks like this text.insert, text.delete. This is stuff that we've sort of like already seen before, and we've actually like worked with in the lecture where we sort of like created our own simple like tkinter text widget, and we were trying out some of these different methods, okay? Let's actually visit this file, this mock_tk file. And it's in the same idle_test directory, and it's called mock_tk.py. And let's actually see what this class, what this file is. And it says classes that replace tkinter GUI objects. Okay. And then you can see. Let's go to the actual class text. Okay. It says it's a semi-functional non-GUI replacement for tkinter.txt text editors. And if we look through just some of these methods, we see index, we see something as decode, but then we have like insert, just like we've sort of seen before. We have get, we have delete. And actually, if you spend a little bit more time looking through this, what the sort of idlelib developers have done is that they've created their own like super simple version of tkinter, okay? Remember, tkinter is this like massive thing that's used in like so many different applications for creating these little text widgets, and there's so much like functionality in them, right? We have these things called tags that we talked about a couple weeks ago. We have, this index thing where we can like index based on certain keywords. But it looks like this text like class here that's in mock underscore tk.py is a simplified version of that, okay? So this is actually a textbook example of what mocking actually does. And if we go back to test format, we can see that we're just creating this like simplified version of text, and we're using that only, okay? To understand what this is actually doing, maybe you can actually read through some of this. Basically, instead of opening up, let's see this comment here, initialize mock non-GUI text-only text widget, okay? What this is doing is that rather than like actually opening up a full text widget and like writing some lines to it and then like reading from it, it's tracking everything in this self.data variable, okay? And when you say like text.insert, all it's doing is actually like adding some string to an existing list, okay? And then if you see like what this like index method is doing, it looks like it's actually calling decode here. And it says that we have like all these different options for basically indexing something. And all it's doing is actually just reading through self.data and getting the correct basically index or the correct element in self.data, okay? And so the reason this is sort of important is because we are now able to like test out all these other sort of features that are built on top of tkinter, okay? So just going back to the sort of analogy before, you can think of like the code that we have written in idle-lib is something like this method here, that's write name to file, okay? But it's using a bunch of other features that are not our features or not our sort of functions. This would be like the tkinter code, okay? So we don't actually care about testing whether this works. That's basically like tkinter's job, right? They'll have their own code base with a bunch of unit tests that test out the text method, the insert method, the delete method. We're just gonna have like a very simplified version of it that we can just sort of check, did it actually write to the place that we expected to, or did it actually just call the tkinter.text like insert method, okay? And so there's a lot of other examples of sort of how we actually mock in this code base. I think what I'll do is save this activity until next time. So I think you can think of this as a bit more of like background on testing, and then we'll have a more like activity heavy lecture next week or next lecture. I think what you could start doing right now if you want is try adding a test for your go-to-line feature, okay? You've added it in like project 2, you modified the go-to-line implementation. I think what you can actually do before then is, maybe you don't have to work on writing the whole test, but it would be great if you could actually go to this go-to-test class and try running it and seeing how you're actually failing now, okay? So you can go to like test_query, where is you? One second. Okay, test query, and then you'll be able to see like go to test, okay? When you run it, I think you're going to probably fail a couple of these tests, okay? Right now there's only 3 tests, test bogus, test bad, test good. Yours will probably fail, and that's okay. See if you can try writing a test that'll actually make it work, okay? And we're gonna go over this in the next class, but it's something you can do sort of before next class. All right, we will end it there, but I'll just remind y'all about all these things that are due. Make sure you ask any questions if you have any confusion about it. Thanks, everyone.
but it's like the extensions and just like the shipping, like make another extension.